Growing population and urbanization has resulted in a significant increase in number of vehicles and road accidents. The WHO report in 2011 recorded nearly 1 million deaths and about 10 million injuries worldwide in various road accidents. According to the Nigerian Road Safety Commission 2011, a total of 726,383 car accidents resulted in the death of 208,665 persons and injuries to another 596,425 between 2000 and 2010. More than 80% of deaths in the accident were as a result of late notification and arrival of the emergency services. Over the years, government and other agencies have been looking for strategy to minimize accidents and increase emergency response time. INEED 2007 defines two types of safety technology. Passive safety technology, which is concerned with the occurrence of an auto crash, and active safety technology for preventing auto crashes. An emergency active technology is the vehicle-to-vehicle communication.
There is no doubt that car safety technology has evolved over time. In time past, cars were just for mobility, and its capability depended solely on the driver's thinking ability. Today, cars have been embedded with sensors, cameras, and radars. According to a research by Ford Automobile in 2008, these tools help them see lane markings as other cars. In an age where we have smart and intelligent gadgets, cars are also going intelligent. An emerging trend in safety technology is the vehicle-to-vehicle communication, which helps cars communicate with other cars.
Vehicle-to-vehicle communication allows cars send messages on speed, location, and direction to one another using short-range Wi-Fi signals and car GPS systems over secure channels 10 times per second using a high bandwidth. V2V communication is a low-cost technology. According to Porter's generic theory on cost leadership, a service can gain competitive advantage with reduced cost. Other capabilities include provision of forward collision warning and prevention of blind spots, as well as lane change warnings. Unfortunately, this technology does not give enough room for a driver to react, hence there is need for training of drivers. However, this technology can also be retrofitted into old cars. Anonymity issues and change in frequency of moving cars are the major threats to vehicle-to-vehicle communication. In future, this technology can be used for robot-driven cars.
With eCall, time is saved. Lives are also saved as well. This is an online emergency response strategy incorporated into a car GPS system that automatically sends message to emergency service in the case of a serious car accident. Even if you're unconscious, the system will inform rescue workers of the exact crash location, and the ambulance will be on its way within a minute. According to Jerry B. 2011, this is a low-cost strategy compared with the remote satellite GPS that are installed at some emergency centers. eCall will save lives and reduce the severity of injuries by cutting down emergency service time to 50%. This will send a minimum set of data that incorporates the GPS location, the direction in which the car was traveling, and the VIN, vehicle identification number. This can also be triggered manually by the vehicle occupant. Considering the current emergency model, according to UTC, the European government has not signed up yet the initiative due to cost concern. As revealed by Jerry D. 2011, the model is being characterized by some disadvantages such as high cost and remote satellite location to emergency centers, time-consuming, and geospatial data error.
According to Dana 2004, gap analysis is the process that involves the identification of gap between the current state and the desired future state. After conducting the gap analysis on the current model, we identify two gaps. Number one is that it costs over £200 to carry out a single process, and secondly, it takes over 5 minutes for emergency service to get to a scene in case of an accident.
However, the strategy for time and the cost reduction based on the gap analysis, we came up with a 3-process model where a minimum set of data that include the GPS location, time, and direction will be automatically sent to the emergency center. This new proposed model will cut cost and reduce emergency response time by 50%.
Considering the future development of eCall strategy, we use BESOR to analyze its technological and legal aspect. According to Oxbridge 2012, with the increase in safety consciousness, technology remains far from being totally exploded. There are numerous additional near-term technological opportunities to adapt to safety measures. Legal. A public regulation for the device GPS and eCall need to put in place to all car manufacturers and private car users to be fitted on the cars to be manufactured as a technological specification.
Good.